In the following video I want to show you a little bit about one of these hand shots, which is 5/4D. There are quite a couple of them, some from this perspective, some from the other perspective, and well, I just want to show you this file, how we set it up, because they are all quite similar. So this is 5/4D. So I go to my scene folder and then to 5/4D. And because 5/4D is one sequence that occurred on different parts of the edit, there is 5/4D and 5/4D2. They are both quite similar, but different parts of the footage. So that's why there's also 5/4D track 2 and 5/4D track. So maybe let's first start for the track. So these are two object tracks. They were quite easy to do, more or less. The camera track is a tripod shot. So if I play back this, it's a bit slow, but you can see the camera doesn't really move that much. So the camera is just a very simple tripod shot. So just 4 markers and then use the tripod solving here, and then you will get quite a good solve error. So the camera doesn't move, it's just rotating. Then we have a track for the hand. And since there is some nice depth, so this tracking device has some stuff coming out of that, so that is providing the perspective. And then I was just looking for frames that had enough movement. So yeah, this and this probably are good because there is some rotation and some movement of the arm. So I guess I was using these frames for the hand solving. Then there is an object track for the head. It wasn't really that important, but I thought maybe I can try and see if it works, and it did. So the solve error is also okay for an object track. So we have in the file, there are 2 tracked objects. One is the head, the other one is the arm. And the workflow was always like first tracking something and then from that creating a new file for the main layout, importing the track, or just using that file and duplicating it and then building everything around that. So this is the track file, and I'm going to open up the main file here. So there is also, of course, the camera. And the tracks. I've colorized the markers so that you can better see what's going on. So here we have the surface of the skin attached to the object track of the head. I mean, the model is horrible, but to generate a shadow, it works good enough. Then there is on these layers, no, where is it? Oh, okay, so here's the helper object that has the object track. So this is using the object solver, and then we've got the armature attached to that. So the armature is, where is it? It's here. And then Jeremy has been animating the hand and the fingers on top of that. And we've got also the animation for these devices. Then this is somehow not in the right place, but you don't see it anyway. There's the hand on layer 2. Then I've always set up the shadow catching object on layer 5. It's just happened that way. I don't. It doesn't really make anything different if you put it on layer 4. But if you want to look at the files, then always look on layer 5 for the shadow catching objects. So that's layer 5. Then there are fake objects just to provide some bounce light. So if I go to the material, this is bluish. This is dark reddish material. Then here is another blue tone. Then somewhere there should be a skin tone. So they were just so that in the metal there are some reflections of the colors from the 2 main actors. So that is that. Then let's have a look at the sequence again. So first I have to change the footage because again I'm not having the 4K here at home. So this is the linear HD. So the challenge was to make the robot hand attach to the face, and for that we just positioned the thumb there where we thought this might make sense and might work. Opacity 0, of course. So back, and now you see how this is set up. So the thumb of the robot arm was a bit bigger than the actual thumb, and of course we had to make it so that you really cannot see the thumb, and that's why in some cases the shadow isn't really matching exactly the shadow of the hand. So actually we would have to put it here, but then, well, it's easier to make it a bit bigger so that it really covers the thumb instead of trying to come up with a complete skin replacement. So that's how we did that. Then one problem here was that, well, we had this problem here. So we thought maybe it helps the actress if we tape the fingers together to make her have these 3 fingers. But the tape unfortunately had this thing coming out of that. So, well, of course we had to remove that, otherwise it would look weird. And for that we could use the in-paint node. So this is just a very rough overview over the file. Excuse me if it's a bit unstructured. Anyway, where is it? Somewhere there should be something. This is the finger. Okay, so this is it. So here we've got the original footage, and then there is a separate mask for this fuzzy thing. So if you look in the masks, there is this red fuzzy thing with one part that is defining where is this red thing, and then 2 extra masks that are cutting it off. So just for Boolean subtraction. So that gives us this thing, and then I'm using a separate RGB node, then increasing the contrast, and then limiting that to the mask by adding that, of course clamping so that we don't get any values that are bigger than 1. Then with a dilate erode node, a little bit of feathering to make it a bit bigger, and then with the set alpha node I'm assigning this black color of this fuzzy thingy here to the alpha channel of my image, of my footage. So that's why here we have this little hole in it. And then if you use the in-paint node, this one that you can find in filter, the in-paint node will take a look at the alpha channel, and if it detects a hole or just alpha 0, then it will take the surrounding pixels and merge them to the inside. So instead of blurring also the original pixels here, it will just take the pixels that it finds here on the edge and then sort of copies it to the inside of this alpha hole. And that's good enough to get rid of that red fuzzy thing. I mean, it's not perfect, but it's really good enough. The problem is on these files, they take very long to render. The reason for that is, you can see here lots of depth of field, and the quality of the defocus node was not good enough to do that. So for that, we have been using the actual cycles depth of field. So in the camera settings here, if I select the camera, you can see here in the aperture, I've set it to f-stop. F-stop number is 2.4. Then it's also focusing on a depth of field empty point somewhere here. Here maybe, well, somewhere here is this focal point. And that takes very long to render. So if I maybe set the samples just to 10, or actually maybe to 2, because my computer is much slower than the computers in the Blender Institute. So it takes a while to render. So in the meantime, I can explain you how we did the background. So for the background, of course, we had to get rid of these red and green balls, of course. And for that, we've been using a clean plate, very similar to the clean plate that we used in 1.2a. The problem here is that because we are using this depth of field of cycles, if we would put the clean plate in the background, that would also be blurred. But because we have been generating this blurred background just by using the original image and then copying it over and painting from the original footage onto a clean plate that has already been blurred, you know, with a cycle depth of field we would get double blur. And for that we have been using different scene files. So if I go to the other scene, which is the BG, the background scene, then here you can see it's the a very similar file, but of course without the hand. It's just the clean plate, and the camera is a different camera, of course the same solver, but it doesn't use any aperture or any depth of field settings here. So if the radius in the aperture is 0, then there won't be any blurring. And because it's just a very simple plane with just a simple texture, you can render with very little render samples. And in the main scene, in the composite, there is then the background layer somewhere. So where is it? Okay, so here is the background layer. It's using the background scene, background render layer, and then of course also the 4K noise. And well, the rendering would take too long now, but basically we are just overlaying that over the footage, and then in the end there is the hand. That's basically how these files work. So there's always this shadow catching object. There are some bounce light generating fake objects. There's depth of field. The lighting is super simple. It's just one sunlight. In the world settings, it's using the background extension file. So it's just using the same, basically, or very similar color settings than you have here in the background plate, just to match the lighting. Very important, in all of the files, set the ambient occlusion distance from 10 to 0.06, so that this shadow here, this fake shadow that you see here, is not too dark. So it didn't end up rendering the background. Maybe I can do that, but it could also be that in my local files I don't have the texture available. Let's see. So this now has rendered the background. Is there something? There's actually something to see here. So this is the background plate, and the only thing that we replaced is the right side, and well, then there's a little bit of noise on top of that, and then it is overlaid over the background, and then here, this is the more or less finished composite. The color balance is something that we used all the time to try to fit the lighting a bit better to the main, to the background. So these are all very subtle changes, but I think it makes it fit a bit better. If you are doing that, if you are using color corrections, and especially what we always did and was super important, adjusting the black levels. So you can see, even though this looks to be as if it would be right in the center, if you look at the y-axis, this has actually an offset of 0.005, and that's important to raise the black levels a little bit, because otherwise this would be solid black, like 0.000. But if you cannot do that, or hang on. Come on. Okay, so if you look at the black levels here, I'm Alt left clicking in this area. If you look at the values that you can see here in the header, these are not 0.000, they are 0.05 and 0.6 and something. So matching the black levels here is very important. So if I disable both of these nodes, then the contrast here would be a bit too black. So now the black levels here are 0.01, so almost black. And lifting the black levels helps. But if you do that, you also have to first unpre-multiply, and then you have to pre-multiply again. If you wouldn't do that, maybe I can exaggerate a bit. So here's, hang on, okay, so here's the file with lifted black levels. Of course, they are much too bright now, but the background is still nice and black. But if I would disable both of these alpha convert nodes, then also the background would be much too bright. Because the RGB curves, if you lift the blacks, then you also lift the blacks of the alpha channel. Which is a bit stupid, but well, that's how it is currently. So we had to use these two alpha convert nodes all the time to first unpre-multiply. So if I disable that, that would mean that you don't have any black background here. So unpre-multiply, do your color corrections, and in the end, then you revert that, you pre-multiply again with your alpha, So if I mute that now and look at that, this is now again a solid black, but we still have these lifted black levels. So that's how all of these files work. And that's it.